So I wanted to show an example of solving for a missing side when your diagram involves multiple triangles. So you can see here that this diagram I have involves two triangles. I have this one here, which is a non-right triangle, and I have this one here, which is a right triangle, and I know that because of this symbol here. The side X that I'm trying to find is right here. It is part of the right triangle. It's across from the right angle, so it's actually the hypotenuse of the triangle. However, if we look at that right triangle and we want to solve for X, the only piece of information that we know in that triangle is this angle 18 degrees. Okay, we do also know that this is 90, so we could, if we wanted to, find what this angle here is by doing 180 degrees, subtract 90, subtract 18 degrees. However, that won't give us any of the information that we need to be able to solve for X. If you recall from our lesson on solving side lengths using SOHCAHTOA, we need to have one of the acute angle measures, which we do, and we need one of the side lengths, which we do not. So this means we need to either solve for this side here, or we can solve for this side here. As mentioned in the module for this lesson, typically what you want to do is to find the shared side between the triangles. Okay, so the one that is part of both of the triangles in your diagram, because then you have a piece of information that is part of the triangle that you actually need to solve for. Okay, so in this triangle, if I find this middle side here, then I will have a side length for the right triangle, and I can find X. So if I take a look at this triangle here, I want to see what I can do to solve for this middle side. Okay, so I'm first going to just label my triangles here quickly so you can see what I'm talking about better. So I'm going to call this A, this B, and I'm going to call this C down here because I'm just labeling that upper triangle. And then I'm labeling my side lengths. Each opposite side, the one opposite to the angle, gets labeled with the lowercase version of the letters. So this is A, this is B, and this is C. So if I'm looking at just that top triangle, the one that I've labeled in blue, I'm trying to find side A. So when I look at my triangles, the first thing I'm asking myself is it a right triangle? No, it's not. If it were, I would use SOHCAHTOA. If not, then I have two options, sine law or cosine law. If I want to use sine law, I need to have an opposite pair. If I look at this triangle, I know this angle A, but I don't know side A. And I know sides B and C, but I don't have an angle for B or C. Be careful here because often I see students say, oh, well, there's this angle here. Is that not angle C? I can set up an opposite pair with 18 degrees and 10 centimeters. However, that 18-degree angle is not in the blue triangle that we're working with, so you cannot use that as your angle. So we don't have an opposite pair, which means we can't use sine law. So our last option is to use cosine law. We know that for cosine law, we either need side, 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 or side, angle, side. And if we look here, we have side, that's 14 centimeter side B. We have our angle, 32 degrees, and we have another side. So this means that we can set up cosine law to solve for side A. Okay, so our first step here is going to be solving side A. So I'm going to set up cosine law, and I'm using the a squared version of the formula because that's how I solve for side A. Okay, so I'm just writing the blank formula here so that you can see it again. And now I'm filling in everything that I know. So I'll have a squared equals to 14 squared plus 10 squared, subtract 2 times 14 times 10 times the cosine of 32 degrees. Okay, so now I'm just going to simplify a bit. I'm going to do a few steps in one. So I'm going to first do this 14 squared plus 10 squared gives me 296. If you would rather do that in two separate steps, that's fine. You can do 14 squared is 196 and then add 10 squared, which is 100. Then I am going to do this step. So I'm doing 2, positive 2, times 14 times 10, and that gives me 280, and that is multiplied by cosine of 32 degrees. Now, the important thing to remember here, I mentioned this in the lesson on cosine law, is we are not going to do 296 subtract 280 because that is not the correct order of operations. Okay, the 280 is attached to this cosine with this multiplication. So this needs to be done first and then subtract, or I like to type it in on my calculator all in one step, but I put a bracket here. Okay, so again, you should have done some practice yesterday with this to make sure that you are confident with the way that you set up and solve. It's okay if you need to show some more steps than what I'm showing, whatever helps you to get the correct answer. So we'll do 296 subtract 280 times the cosine of 32, and I get 58.546 approximately. If you're going to clear your calculator, make sure you put those 4 decimal places. Otherwise, I just leave the whole number on my calculator. Then the last step here is to take the square root of both sides because I want a, not a squared. So that gives me a is approximately equal to 7.7 centimeters. Okay, remember for side lengths, we will round to 1 decimal place. Sometimes because it is an intermediate step, meaning I have to use that side to solve for something else, I might keep 2 decimal places. It's fine if you just keep 1. Typically, that's how I'll do the solutions. But because you're using side A to solve side X, it might be nice to either save that number to the memory on your calculator or to include a few more decimal places. So now that I have found side A, I'm going to write that here on the triangle. So 7.7 centimeters. I'm putting it on this side just so you can see it, but also because this is a shared side, that means that it's 7.7 in this blue triangle, but it's also 7.7 on my right triangle. So I can use that now. I have one side length here, and I have one acute angle, so I can solve for x. So if I look at the right triangle, I still have BC, I'm just going to call this vertice here D, although we don't really need that for the sake of a right triangle because if you recall, we label right triangles with opposite, adjacent, and hypotenuse, not ABC. So my reference angle is here, the 18-degree angle, so I'm labeling my sides opposite, adjacent, hypotenuse relative to that angle. Okay, so you'll notice I do this in a different color so that I don't confuse my labels of my triangles. In this case, it's fine because one triangle is labeled with little a, little b, little c, and the other triangle here is labeled opposite, adjacent, hypotenuse. But I still like to do it in separate colors just so that I don't confuse things. So I have my sides labeled and I'm asking myself what kind of triangle is this? Because if it is a right triangle, I can use SOHCAHTOA. So I look at this, it is a right triangle, right? That's why I labeled it opposite, adjacent, hypotenuse. So I can use SOHCAHTOA to solve. In order to do that, I ask myself which side do I have, which is my adjacent, and which side do I want, which is my hypotenuse. And that is going to help me decide which ratio to set up. So if I look at SOHCAHTOA, I'm picking the one that has A and H, which is cosine. And then I'm setting up my ratio. So I would have cosine of 18 degrees is equal to the adjacent, which is 7.7, divided by the hypotenuse, which is x. If you prefer to write the blank formula and then fill everything in, that's fine. As you get the hang of it, it's okay if you skip the blank formula and go right to this filled in one. Now I need to isolate for x, it's on the bottom, so first I am going to multiply by x on both sides, because that will cancel this out of my denominator. I'm just going to show it like that. Then I will have x times cos 18 is equal to 7.7. And my last step to isolate is just to divide both sides by cosine of 18 degrees to fully isolate for x. And again, it's a side length, so you're going to round to just one decimal place. So we have 7.7 divided by the cosine of 18, and you get 8.096. So I'm going to round this to just 8.1. And because I gave you the units in the diagram, I'm going to write 8.1 centimeters, and that is the final answer. Okay, so your main takeaway here, the skills you're using are all the skills we've learned so far. So SOHCAHTOA, sine law, and cosine law. The important thing to remember here is that typically you want to find the shared side first, and then you're asking yourself these questions to figure out which method are you going to use to get to what you need. And there will always be at least 2 steps when you are working with a diagram that involves multiple triangles.